Hi, today I'll show you how to build a smart pipeline using Python and GPT that automatically classifies logs and diagnoses vehicles and drivers. For the application interface, I use the no-code platform Flutterflow, so let's dive into the details. This diagram shows a modular architecture based on the interaction between AI agents, a database, and the front end. This is where all the AI components live. Log classifier agent, the main coordinator. It receives raw logs, classifies them by type, driver, vehicle, and forwards them accordingly. Vehicle check agent analyzes the condition of the vehicle, engine, brakes, battery, etc. Health advisor agent evaluates the driver's behavior and provides health-related advice. All agents use a OpenAI model as their logic engine. Firebase database stores all diagnostic results, receives reports from vehicle check agent and health advisor agent, serves as a bridge between the backend and front end. The front end is built using Flutterflow, retrieves data from Firebase, and displays reports to the user. Let's take a look at the interface I created with Flutterflow. This app reads information from Firebase and displays real-time updates. On the screen, we see a dashboard and, for example, a rating for a car part currently 7. Let's change it to 8 in the database and confirm the interface updates. Perfect! It works. Now I'll launch our backend pipeline to read and process logs using the AI engine. Great! The pipeline has finished running. Let's check the app interface, and yes, it updated. Now let's take a closer look at the backend. As mentioned, we have 3 agents. They're built using the OpenAI AgentSDK. The main goal of my project was to explore how structured inputs work and how to effectively use them. Let's start with the basic agents. Vehicle check agent, an expert in automotive diagnostics. It runs on a language model, by default, GPT-4o Mini, receives input about the vehicle, and generates full reports. The agent receives a unique vehicle ID, a list of observations about parts of the vehicle including timestamps, statuses, issues, etc. It performs the following steps: groups observations into categories. Only if they relate to tires, engine, fuel system, brakes, battery, other components are ignored. For each supported part, the agent assigns a health score from 1, poor, to 10, excellent, writes a brief summary of the current condition and then gives personalized improvement recommendations. It returns a separate report for each part, in the vehicle check report format: vehicle ID, vehicle part, health score, summary, recommendations. After generation, all reports are converted to dictionaries where the vehicle ID is retrieved, a document is created in the vehicle reports collection, and data is saved with a timestamp. The driver agent works similarly, but has a simpler output structure. Now about log classifier agent. This agent reads raw logs containing info about drivers and vehicles, classifies each log as driver-related or vehicle-related, then groups results into 2 categories: driver events and vehicle events. Each log contains timestamp, the time of the event, driver ID, and vehicle ID, message, a plain text message, for example, engine made a strange noise. The agent processes the logs and determines whether the log relates to the driver or the vehicle. For drivers, creates an object with an event, for example, driver felt dizzy. For vehicles, extracts the vehicle part and description. Now about full pipeline execution. Run full pipeline. Step 1, log classification. We get clearly separated driver and vehicle events. Step 2, data preparation. Extract and format driver events and vehicle events to send to other agents. Step 3, passing to AI agents. For the driver, send data to health advisor agent, which evaluates the driver's condition, and get a report, score, summary, recommendations. For the vehicle, send data to vehicle check agent. It creates a report for each part, tires, engine, etc. Then everything is saved to Firestore. In this project, we explored structured outputs in OpenAI's AgentSDK, which brought several key benefits: full control over output format, Using output, type, and pedantic models, we strictly define what the agent will return. Reliability and predictability. The model doesn't just respond with free text, it fills predefined fields without surprises. Flexible integration. Structured outputs can be directly sent to databases, UIs, or other services without extra parsing. Scalability. You can plug in new agents, scale the architecture, and add logic at any stage. So, here's another argument proving ChatGPT is more than just a chat toy. We've researched how to build a full-fledged system using agents, and it only gets more exciting from here. Subscribe for more hands-on practice and zero fluff. See you next time.